So let's first review what you learned before in calculus 1, the derivatives, right? Let's do derivative. Let's start from sine. So the derivative of sine, let's give us cosine x. Of course, this is not just about sine x we are go over. We also have to think about if the inner function gonna change. Let's say I change my inner function, sine 3x. I take a derivative of that. You cannot just do for the sine compared to the first problem we just did, right? So we first have to do derivative of sine, which is cosine 3x. But we have inner function right now, so we have to follow the chain rule. The chain rule is times inside the derivative. So the final answer will be 3 cosine 3x. Of course, the inside could be any function we want. I can give x squared. I take the derivative of that. That's going to be cosine, because sine is going to become cosine. Not going to change anything after derivative, but we have to times inside the derivative of x squared, which is 2x. All right, so the final answer, if you want to write, you put 2x in front, and that's going to be cosine x squared. This gives us idea if I take integration from the right side, I should get something back and plus a c. So this is one way to look at if I have inner function. But sine x could be an inner function for something else we learned before. I can have sine to be the base. And this goes to, let's say, power of 2020. Now I take a derivative. All right, this is the same way you look at if you write a power. So that's a power of 2020. And now we take a derivative of this. So this is not the same as the one we just finished, because sine x is our base. This is exponential function we have. So when we're doing that, we first have to use a power rule, right? So bring down the 20. Then decrease by 1 for the exponent, 2019. We didn't finish it because we still have my base, which is my inner functions. Follow the chain rule. So we have to take a derivative of sine. Now we're gonna get 2020 times the sine power of 2019 times the derivative of sine, which is cosine. Good. Everybody good so far? Any questions?
Yeah, I'm good.
So this is just a review, right? Everybody is fine so far?
Yes.
Okay, now I'm gonna erase the top, right? I'm gonna leave the sign right here, but I'm gonna erase right here. So let's talk about integrations right now. So before that, let's do one more. So we have cosine, a derivative of cosine, that's gonna be negative sine. Now let's discuss about integration of sine. If I take integration of the sine, this is gonna give us, what should we get? Can someone help me right here?
Minus cosine.
Minus cosine. Any questions so far? Right, we just do it backwards. You also have the formula sheet. So that's going to be minus cosine plus c. Now if I do cosine x, so derivative of cosine x, that's going to be sine x plus c. Right, this is two very basic one you have seen before. Now we're going to change the inner function or give the power to compare how we're going to solve it. Then we're going to have different combinations of sine, cosine to check how can we solve that. First, what I want to look at is if I'm taking integration of sine, this is very depends on where we look at it, inside or exponents. Then we're going to decide which way we're going to follow. So we could have inner function right here, or we could have exponent right here. Then we have to use different ways to solve it. Let's start in, we have inner function here first. So let's say I have sine 3x dx. In order to solve this, we cannot just give this to be negative cosine x because we have u inside, right? We did a chain rule before. So right here, we need to find our u prime. Our u will be my inner function. We must have our u prime. So since my u is 3x, u prime is a 3, we must have a 3 in front. So we create a 3 by ourselves. That's going to be 1/3, 3 sine 3x. Now I prepare 3 to combine with my function here. Now it's done. That's going to be 1/3, follow the original negative cosine 3x plus c. That's it. Any questions? Everybody's good?
Yeah.
Now let's look at if I change the inner function. Let's say I have sine 3x squared dx. My first question, can we solve it? Or if there's something missing? Or can somebody help me to sit up so we can solve this?
u equals 3x squared and then u prime equals 6x.
So we need a u prime. Do we have it?
No.
So we don't have it, we cannot solve it. But if we can add this to it, right? Let's say I change a new problem. This is our problem right now. Now can we solve it?
Yes.
Can somebody tell me the final answer? I just need someone to tell me what the final answer is. Our u prime is 6x, right? So our u is inner function, which is 3x squared. Our u prime is 6x. So we do have 6x in front. We already prepared everything to solve this problem. So now it's done. So our final answer will follow the rule we have. Sine goes to negative cosine. So that's going to be negative cosine 3x squared plus a c. Okay, everybody's good so far? Any questions? If everybody's good, so we're gonna move on to the different style of the problem, right? So different style will be if this is not inner function we have, and it's something for the exponent we have. Let's say I add exponent to the sine. Let's say we have 11 right here. I'm gonna add a cosine x in front. Now let's look at this problem here. This problem, the first thing I look at is I see there's 11. When I see this 11 right here, I consider this gonna be my base. Now I'm looking at this problem as exponential function. I don't even care about the cosine x in front. I think, okay, the first thing I have to do is try to use my base to be my u. Now I'm doing my u prime, which is sine, derivative sine is cosine. I have the formula on the top. Now I look at if I have cosine or not. I do have it in front. Now the problem is done. We follow the power that is sine x 11 plus 1 over 11 plus 1 plus c. Now you see the difference when we have exponent or the inner function. We are using a different way to solve it. How we use a different way to solve it is depends on how you give the u whenever it's exponential function, which we learned before that my base will be my u. If the inner function we have for sine, we're going to define the inner one to be my u, take derivative to find the u prime. Right? That's similar to what we learned before. If everybody's good, then we can move on. Any questions so far?
Professor, can you do one more a problem like that?
Which style? First one or the second type?
Can I do the first?
You mean if there's something inside?
Yes.
Okay, I need you to with me, and I'm asking you questions so you can help me to answer it, right? Okay. So let's look at, I'm giving a new problem, sine e to the x dx. We have sine, we have e to the x. Now I ask you about which type of style we have. Do I'm doing for the sine or do I'm doing for the e to the x?
E to the x?
I'm considering this problem for trig function problem or e to the x problem.
Mm-hmm.
Is that e to the x or sine problem?
E to the x problem. No.
We have to know which function is inner function, right? Which function is inner function? Which function is inside?
E to the x.
E to the x is inside, okay.
Yes.
Inner function is not the type of, what are we doing? Inner function can only be our u.
Mm-hmm.
Right? We are doing the sine function right now.
Okay.
Our inner is e to the x, okay?
Okay.
Right now it's very clear this is trig function problem we have dealing with, which is for sine. Now the second question I'm asking you is, can we solve this? Do you think there's something missing for our problem?
The x outside.
If I have x outside, can that help us to solve?
Yes.
So if my u, my u is will be e to the x, right?
Mm-hmm.
What is the derivative of my u? What is the u prime gonna be? E to the x, derivative of e to the x. Somebody help right here?
Cancel out.
That's gonna be the same, right? E to the x, derivative of e to the x has to be the same.
Okay.
So the x in front not gonna help.
Okay.
because we must have the u prime in front. Now I'm going to change that. If I have e to the x in front, now we prepare everything. Can somebody help me to get a final answer? I already have my u prime. Anyone can help to solve this?
Negative cosine into the x.
Negative cosine, right? Because sine becomes negative cosine after integration. And what is inside?
Let's see. E to the x.
Perfect. That's it. So the final answer will be negative cosine e to the x plus c. So whenever we have u prime, we are almost done, right? Depends on how, sometimes we may not have exactly a u prime. You have to do something. That's what we learned before. Okay. Anything else?
That's all. Thank you.
All right. So anybody else? So everybody's good. Now let's look at something maybe a little bit harder than this. Because sometimes we do not have u prime to prepare for solving. Right? Let's look at integration of sine squared. Of course, from the idea we have, when I see the square right here, I know this is an exponential function. And sine is my base. In order to use u prime method, I must have cosine x in front. But for this problem, we don't have it. So this is not a u prime problem anymore, unless I can make a cosine x in front. How can we make a cosine x in front? We have to look at our formula. The sine square formula, if you look at our formula sheet, right, everybody should have that. The first formula we have is, which everybody should remember that, sine x squared plus cosine x squared equals to 1. Right, so this is our identity for sine squared plus cosine equals to 1 always. And you should watch the video I send you to see how we prove it. So if I'm doing that, I want to use this formula. If I use that, so sine squared will be 1 minus cosine x squared. This doesn't really help because my cosine x squared need a sine x in front too, because if this is my base, I take a derivative, I should have negative sign in front, but we cannot have it. Right, so that means this formula not going to help us. Then we have to look for more formulas. Right, I want you to look at the formula sheet to see if there's anything I can use. Right, you can go move down to the formula to see which one you think may be helpful for us to. Right, there's a lot of formulas we have. I want to use spatial look at what is a sine square. Could it be rewrite? Can somebody look for the formula sheet and tell me what the sine square equals to using the cosine 2x? Anybody find it?
Can you do sine square is equal to 1 over cosine square?
1 over cosine square. Sine square is not equals to, hold on. Are you sure you see the right formula? We have a spatial formula has fraction. You can continue to look through. You should say something is 1 subtract cosine 2x. Everybody see that? This is double angle formula you learned in pre-calculus. Now let's see why I pick this formula right here. I'm gonna rewrite the problem here. All right, so this way is not good because that's not gonna need me to solve the problem. The problem is still remaining. I don't have my u prime in front. So now I'm gonna using this formula right here. So I'm gonna rewrite a sine squared to be 1 subtract cosine 2x over 2 dx. After I rewrite, let's break this into 2 fractions. That's going to be 1/2 subtract cosine 2x over 2. And this part, first term we have, that's very easy to solve because it's half, constant number. Result will be half x subtract. So the second part we have is cosine 2x over 2. Let's look at this one. So we don't have exponent right here. I have inner function. Now it's very clear. The inner function is 2x and outside function is cosine. This is trig function. We need to find u prime for my inner function. Now I'm gonna rewrite this as a half. This is a half I put in front. All right, so I'm gonna rewrite it as cosine 2x dx. Now the u right here will be 2x. Our u prime will be a 2. Now I'm missing a 2. We can create a 2 by ourselves. Becomes 1/4 because I make a 1/2. 2 cosine 2x. Now we prepare our basic integration of the trig. That's give us 1/4. So integration of cosine 2x will be sine 2x plus c. That's gonna be your final answer. Any questions? So we did a step-by-step go through the whole thing, right? So first we choose the right formula to apply. Since I have sine squared, it's very hard to find one single cosine to prepare for our u prime method. The way we're doing right now is we use the identity so we can lower down the degree. So I change the second degree to be the first degree, but that's using the double angle formula, 1 subtract cosine 2x. So after I replace to a new style, so we are able to solve it. Questions? If everybody is fine, now let's move on to have sine to the third. No matter which method we starting to think about it, we first have to think about it, okay, does the u prime work? If the u prime gonna work, that's gonna be a faster way we can solve it. Right? If the u prime is not working, then we have to figure out, okay, what else we should create or use because you have your formula sheet. Now let's do third. So this is sine to the third power. Now let's think about what can we do. Okay, can we have something in front to prepare? Right, I can move one sine in front. Because I'm trying to think about this is my exponent. This is my u, my base sine x is u, so derivative of sine x should be cosine x. But I have my, take out 1, which is sine x. That's not good. Sine x can only prepare with cosine to the power. Everybody understand what I'm talking about, right? So I'm gonna go over this part, what I'm thinking. After understanding the problem for exponent, we understand if this is sine, we should pair with the cosine. I just gave a power right here to help you understand, right? So this problem is going to be very easy because derivative of sine, derivative of cosine give me the negative sign. Almost done if I have a negative sign. If I have cosine in front, this can be paired with sine to a power. Sine derivative is cosine. Now this is done. Right, so this is a way we think about the pair sine with cosine, cosine with sine. Now I have a sine right here where I need a cosine to make this form. Now the question is, can I change this to be a cosine? If we can do that, now we're done. Anyone can help? Can anyone help right here?
Sine square x is equal to 1 minus cosine square, 1 minus cosine square x, yes.
In order to get a, very good, so in order to get the cosine, we can use a formula right here. Right, because sine x, it is 1 subtract cosine x squared. Sine squared. So I'm gonna rewrite. That's gonna be 1 subtract cosine x squared. The reason we're doing that, we're trying to prepare to this form. Now let's say if we change that, can this help us to solve this problem right here? I'm gonna continue right here. So that's gonna be integration, and we're gonna distribute it right here. That's gonna be sine x, subtract sine times cosine square. I'm gonna write this way to say that's an exponential function form. Now this has no problem to solve. And let's look at it right here. So our base right here is u equals to cosine x. Derivative of a cosine x, u prime, that's gonna be sine x, which we already have in front. Now we're done. So integration of sine, that's gonna be negative cosine minus. This is perfect for the power, so we have cosine x, 2 plus 1, 3 over the 3 should write it in the middle. Let me just rewrite that. 3 at the power of cosine x over 3 plus a c. That's going to be your final answer. Okay. Any questions so far? Everybody's fine? If everybody's okay, now let's have a new problem right here. How about I just have sine x and cosine x? Can we use the same idea we just had to solve this problem? I have sine x times the cosine x. I want to follow the idea of doing the things like this one right here. Can we do it? Can anybody help me to do that one? I think we are able to do that. Can anyone help?
Would you put u as cosine x?
If we put u as cosine x, okay. Everybody can say that. Right, I'm gonna use this one to be my base. So what is the exponent we should give for the cosine x? 1. Now everybody see the change I made. I basically, I didn't do anything. I just realized the exponent for my x, cosine x is to the 1. So now I follow the power, which the base is my u is cosine x. My u prime the same as sine x, we just did. Now this is done. That's gonna be cosine squared over 2 plus c. I want everybody copy this down. Right, copy this. Cosine x squared over 2, copy that.
Professor, can you explain how you got the 2's?
How we get a 2?
Yes.
What is our exponent for my original cosine x?
1.
Our original cosine x.
1.
1, okay. So we increase, right? Because we already have u prime.
Mm-hmm.
This is exponential function form. So we increase by 1.
Oh, okay. Got it.
Right, so that's gonna be 1 plus 1 over
That's 2.
1 plus 1. That's
Got
gonna
it.
be cosine x squared over 2.
Got it. Thank you.
Let's do this again. We have the same problem right here. I'm not consider this exponential function form because I may not realize I have exponent here is 1, right? So what I have to do is I look at the formula sheet. I found a special formula. There's one formula give me sine 2x equals to 2 sine x cosine x. I have no problem to do integration of sine 2x. So now I'm using this formula to do it. In order to use this formula, I need a 2 in front. So I make it 1/2 2 sine x cosine x. Now I prepared to use the formula. Now the problem change. The problem change to be 1/2 sine 2x. Sine 2x, the basic trig function. I need my u, which is my inner function, 2x. The u prime is a 2. I don't have it. I have to do one more time. 1/2, make one more 1/2, You have a 2 in front. Now I can solve this to be 1/4. Integration of sine is negative cosine 2x plus c. We have the same problem using the 2 different ways, but it looks like we have different answer. The first answer we have right here, and the second answer we have is right here. How do I know which way is right? Right, because everybody may use a different way solving the problems. That's the reason you learn this in pre-calculus. You can prove if the 2 trig functions we have are identical. Right, so we're gonna go over a little bit here to see if they are the same. That means both methods are okay to solve the same problem right here. Right, so what we want to prove is this. The first way we have the answer right here, it's the same as what we have right here. We just basically go over cosine square formula. All right, let's do cosine square. I want to look at the formula sheet we have. What is cosine x squared equals to? Use the double angle formula. Can somebody help me right here? One going to be plus, one going to be minus. I forgot which one we should have.
1 plus cosine 2x by 2.
1 plus. Okay, 1 second. So that's going to be 1 plus cosine 2x over 2 over 2. Anybody see that? Let's simplify a little bit right here, right? So that's gonna be 1 plus cosine 2x over 4. Everybody's good so far? I just applied the formula to our problem right here. All right, so we can also use the cosine equals to sine. So the cosine is 1 subtract this is just a review of what you learned before. So I just gonna do one more. 1 subtract sine x squared. I didn't do anything, I just rewrite it. All right, so now this is gonna be using the same double angle formula for sine. That's gonna be 1 subtract. So the double angle formula for sine is 2, 1 subtract cosine 2x over 2. Right. If you follow that, that's gonna be 1.
You have no way that's enabled. Do you want to open it?
Subtract a half plus.
You have no way that's enabled.
Alexa, stop. Right, so if you simplify right here, you're gonna get the same answer. That's gonna be a half plus cosine 2x over 2 divided by 4. That's gonna be give you the same answer right here. Now, so that means our answer right here is going to be equivalent to 1/4 plus cosine 2x over 4 plus, let's see. Now let's look at our answer right here. Is this the same as this one right here? This is our equation, right? So our equation is, for my second solution I have, my answer is negative cosine 2x over 4. My first problem right here, we are getting a positive and a 1/4 right here. Now that the same or different? Can anybody help me right here?
It looks different.
So, but is there, did we make any mistakes? It must be the same, right? No matter how we solve it, we should have the same answer. There must be a mistake we make. Or somebody didn't catch the mistake we did. The sign should be the same. Otherwise, the problem is wrong. Let's look at right here. We're starting. Is there anything looks? So my u is cosine x. My u prime is?
U prime must be negative sine x.
Now we found something wrong here. Everybody say that? The u prime must be negative sine. We didn't catch this mistake right here. We should have a negative sign. The final answer is supposed to be negative cosine squared. So the answer must be negative 4, negative, negative, negative. So the answer should be negative 4, negative 1 over 4, negative cosine 2x over 4 plus c. Is this the same right now?
Yes.
Yes.
Right, because now everybody understands. Look, the sign is different for cosine's part. They are not the same answer. For the constant number, doesn't really matter because constant can combine to get our new constant. So now these two answers are equivalent. So this makes our exam very hard because when you're making small mistakes, your answer is going to be wrong, right? So you have to show me step by step how you solve it. Small mistake, I'm not really care. So you must show me step by step how you solve it. And you don't have to worry about which method you do it. Even you gave different answers, you don't have to worry because what I'm checking your steps to make sure you understand how to solve it. We don't care about the answer if everybody has different answer, but we can prove it. But this is not our class. Our class is understanding how to solve it step by step. Okay. Everybody's good so far? Any questions? We just show how we use a different way to solve the trig functions. And we may get something different, but we can always prove the questions are the same, the answers are the same.
Professor, is it possible you could do one more like this?
We can do something different, but I mean, we don't have to prove it, right? This, I just want to show you they are the same answer basically from the pre-calculus. You know how to prove it, right? You don't have to prove it. either you do the second method or the first method on the exam, gonna be fine. In the future, we're gonna use the third method to solve this. Okay.
Okay.
Right. Now we move on to because we did a sine squared, sine to the third. Now let's look at sine to the fourth. Then we're gonna do more combinations of sine, cosine. Then you can see the more details. You see, very easy to making mistakes, right? So now let's think about sine to the fourth power. Still, we want to do the u prime method first, right? Sine to the fourth, we need a cosine x in front. But one single cosine x is very hard to make, right? So we can try to make a 1 in front. Now I have a sine to the third. Sine to the third, we don't have any formula for it, right? Our formula is a square, always. So this is not good to starting with. Our formulas are basically square, square. Now I'm gonna change to a new thinking about how to solve that. Maybe this is not good, so I can try to have sine square, sine square. Square is the exponent we have. Whenever this exponent is large, it's hard to solve. Is there a way I can make the exponent smaller? All right, this is what I'm thinking right now. If I can make the x squared smaller down to the first degree, the problem gonna be easier, right? Is there a way I can have sine squared down to the trig for the first degree? This is what we just did it. Because sine squared is able to rewrite into the, what do we have right here? 1. Can somebody help me here? Is this subtract or adding?
Subtract.
Everybody see that, right? So sine is subtract, cosine is adding. So that's going to be a subtract. I'm going to do the same for my second sine squared. That's going to be 1 subtract. Now basically I have a perfect square. So that's going to be 1 subtract cosine 2x over 2 squared. X over 2 squared. Now let's see if we can do this, because when I say the 2, I'm thinking about a u prime, the inside u prime. So derivative of cosine will be negative sine. It's going to be very hard to make a sine in front, right? So u prime method is won't work right now. So the only thing I'm thinking right now is, okay, let's do the basics, right? Whenever we see the square, what we done before is we just open it. Let's just open this to see if we can continue to solve this. So when we open it, I'm opening right now. First, I'm gonna do 2 square, right? There's gonna be square here. So that's gonna be 1/4. I'm gonna put in front. I'm just gonna square 1 minus cosine 2x. So that's gonna be 1 minus 2 cosine 2x plus cosine 2x squared. I didn't do anything. What I did just open the parentheses, right? Use the a plus a minus b squared. That's going to be a squared minus 2ab plus b squared. Or you just FOIL it and solve this. We get the same answer. Right now, let's say 1 by 1 to see if we can solve this, right? So 1, that's not a problem. 2 cosine 2x, that's not a problem because this is basic trig. How about cosine 2x squared? Can we solve this? Can we solve this one? Anyone? Right, we know how to solve the first two. How about the third part? Cosine 2x squared. What's the formula or the method we should apply right here to get that part done? Then this whole problem is done.
The double angle formula.
We can use the formula again to decrease the exponent right here, right? So let's do that. So 1/4 integration of 1, that's going to be x. Integration of cosine 2x. My base is, inner function 2x. And u prime, it is 2. I have it. So this is done. So the integration of cosine, that's going to be sine. So that's going to be minus sine 2x. Any question right here? Everybody's good? I did it very fast, right? So 2x is my inner function. My u prime is a 2. I do have a 2 in front. This is done. Integration of cosine, that's going to be sine because derivative of sine is cosine. The inverse of integration of cosine is sine. So that's going to be sine 2x. Now the last one we have, that's going to be 1 plus, I'm using the formula, 2x divided by 2 dx. If we continue to rewrite this part, that's going to be a half plus cosine 2x over 2. So this is just going to be repeating what we did right here. That's the same type of problem we have. Now we just solved sine to the 4th power. Okay. So sine to the 4th looks like the most complicated one, right? Because it's very high exponent. We did it once to down to the square, basically down to right here. Then we continue use the formula to make the degree lower down. Now we can solve this. Okay, that's for the sine to the 4th. That means you can apply to the same way of thinking to do cosine squared, cosine to the 3rd, cosine to the 4th.
Professor?
Mm-hmm.
Wouldn't it be 1 plus cosine 4x by 2?
Hold on. Because we're using the double angle formula. Hold on.
Yes, there was a 2 inside.
Yeah, we have to double that. I suppose go over this part. Let me circle right here. So when we use the double angle formula, we are starting here is 2x. That should be 2x times the 2, which give us a 4x. This is 4. Right, so this is 4. Okay, any more questions? Everybody so far is good? Everybody's good. We're gonna move on to the next type of problem is a combination of sine cosine. All right. Before I move on, any more questions?
We can just put the constant at the end, right?
Yes. I didn't finish the whole thing, right? I mean, we're gonna do the homework, so homework you can
Wait,
do more practice.
Professor, don't erase it.
No, we're gonna post this. I record. Don't worry. I already record. I'm gonna post it on YouTube. Right? I'm gonna send you the link. Okay, don't worry.
All right. Sorry.
Okay. So everybody is fine for the 4x, right? There's a typo. I was talking too much. All right. So now let's look at the combination of sine, cosine. What I mean by a combination of sine, cosine is we already see one combination, sine x times cosine x. Right, but this could be give us an idea about how the combination can help us is whenever I have sine x in front as my u prime, my cosine, it could be goes to any power I like, right? Power of 2, power of 3. Before we did 1, the 4, 5, the 2020. It could be negative, -5, -6, -1. Maybe you can think about it. Okay, this is one way. Second is I have cosine in front, right? A sine is my exponential function. Well, this can have any degrees to apply. If this happening for our problem, it's not going to be hard to solve because that's going to be a standard way of U prime method because you already gave us, if this is our base, derivative of cosine will be negative sine. It's already prepared for you. If this way we have, the sine is my base, derivative of sine is cosine. It's already prepared for us. This is basically the power exponential function form to use. But sometimes we may not have one single sine or cosine in front. It's our job to make it. Or you have to figure out a way to make it. That's what we're going to look at it. A different exponents for cosine x and sine x. Starting from one even, one odd. So my sine x is odd. I mean, sine x is even 2. My cosine x is odd. Right, we want to apply the idea. We need one single sine or cosine in front because I want to prepare for my u prime. Okay, now let's look at this problem here. I have sine squared cosine to the third. Is that possible? I have one in front. And which one should I put in front? Sine x or cosine x?
Sine x.
So if I make one single, right? What are we talking about a single one? So I put a sine x in front. Then let's say what the remaining is. Remaining going to be sine x.
Oh, you should put, I think.
To the third, doesn't matter. Let's try it.
Okay.
Okay, don't worry. There are only two different ways, either sine or cosine, right? So that's is I did for the sine. Oh, maybe I feel this may be hard. Let's change it. I'm gonna use cosine x in front. I just want to say what the remaining is. Don't worry about it. So that's gonna be sine squared. That's very good to look at it, to help you understand. Help everyone to find out what's the best way to think, right? Okay. So this is the second way I'm doing is I just pull out one cosine x. Now the cosine x becomes the second degree, right? Because I already have one in front. This times that will give me third. That's what I'm starting with. Which way is the right way to solve? It's very clear because when we're dealing with sine cosine, it's always degree of 2. Because sine squared plus cosine squared equals to 1. Right? That's something we can always exchange sine and cosine. when we need it. When I need a sine, I can exchange cosine squared to become sine squared, or we can exchange it. So what does that mean? When we're dealing with cosine in front, everything else must be in sine form. Otherwise, we cannot use exponential function form to solve the trig problems. If we have sine in front, everything else must be cosine. Otherwise, we cannot solve it. Let's look at our first method here. The first way we did is I pull out one sine. That means everything else must be what?
Cosine.
Must be cosine. Now let's look at this. It's already cosine. This is good. How about this one? This one is not good because it's not square. If this one is a square, this is perfect way to solve it. Since this is not good, so let's look at my second one. I have cosine in front. Everything else must be sine x. This is a sine x. This is not a sine x yet. Can we convert that to be sine x?
Yes.
Because we can change the cosine x squared to be 1 minus sine squared. Everybody got it? Any questions? Now I'm converting right now because I know I'm able to change the cosine x squared to be 1 minus sine squared. After this change, we have to open because we are trying to get the cosine combined with the sine, right? We have to open the parentheses. So now I open the parentheses. I'm gonna do this first. So that I remember that's gonna be sine squared minus sine to the fourth. Then I times it. So that's gonna be cosine pair with my first one here, sine squared. Dx, subtract, because I have negative sign here, that's gonna be cosine. Prepare my second one is square times square, that's gonna be sine to the fourth. Now I'm making this second type of the combination. One cosine in front, pair with the sine to the any power, right? The power is 2, their power is 4. Let's just finish the whole problem. I'm gonna erase the ideas we have. So you know, first thing we want to do is give one single x or sine x, cosine x in front. All right, let's do the first one. First one, let's look at it. So this is a sine. Derivative of sine is cosine. It's done. Second one, this is sine. Derivative of sine is cosine. This is done. And we just have to follow the exponent to finish that. So the first part, so that's going to be sine. Degree 2, add 1, that's going to be 3 over 3. Subtract, that's 4. So that's going to be sine 4 plus 1. That's going to be 5 over 5 plus c. That's it. Okay. Everybody good so far? Any questions? That means I can just keep on changing the exponent and to solve, right? So what can we change right here is, if I still have sine x to the square, so that's even, I can add numbers for my exponent. That means I can change this to be 7. We just have to think about, if I change a 7, What should we do? Can we still solve it? Is that the same problem? Can somebody help me right here?
I feel like we should put the cosine x in front, one cosine x in front.
So we still try to put the cosine x in front. So let's just try that. So let's put a cosine x in front. I just want to make sure I can convert everything else to be sine x, right? So that's gonna be cosine to the 6. Now the question, do we have issue to change cosine x to the 6 to be sine? I want everybody to try that. Then tell me what is the sign gonna be for cosine x to the 6. All right, let's everybody do that right now. Look at our formula, then try to convert that to be everything to be sine. If you are able to do that, you have no problem to solve this type of problems in the future. Give everybody 5 minutes. If you're able to solve it, just show me your hand, right? If you're done, show me your hand so I know you finish it. Anybody finish? You don't have to solve the whole thing, right? I just want to see if you can convert cosine x to the 6. Or you think you are able to convert. This is only the idea we have, right? This problem is not going to be easy to solve. The 6. Well, only you can do the square. To the square, so the square of cosine is 1 subtract sine. I don't have to go on because I know after I multiply, I will get all terms of sine in a different degree, but you don't have to continue. So now I know that's gonna be paired with cosine. So that's gonna be cosine pair was a lot of sine to different degrees. So this problem can be solved. Everybody's good so far? Everybody's fine? Any questions before we move on? So that means we also can change the style of the problem to be one odd number for sine, right? This could be changed, and an even number for cosine. So let's have 2, this could be 3, and that's the same problem because we just have to have 1 in front. So for the odd right here, I can put a sign in front, right? Okay. no one has questions, we move on to a different numbers for sine and cosine. Since not many people talk today, so I do think this may be a hard topic. I want everybody to send me a feedback about today's lecture so I can see if I need to go over something next week, right? Because we're gonna meet here every Friday at 1 o'clock. Okay, let's change this to, so we did even and odd. Let's do both are even. So we did one before, which is sine, cosine. That's even, and that's odd and odd. Right? Let's do square, square. Both are even right here. How can we solve that? So when I say the square, the first thing I'm thinking is, okay, I can do sine square plus cosine square equals to 1. So if I'm doing that, that's a formula I'm going to use. That's going to be cosine square is 1 minus sine square. So I can distribute it right here. That I get is sine x squared minus sine x to the 4th. We did sine square before, right? Since everything we done before, you can just apply to right here. I'm done. I did the sine to the 4th before. Oh, we just copy that right here. Now I'm done. Do we have a different way to solve this? Of course. You can think about the different formulas. To think about that is we can also use the combination of sine, cosine, have a 2 in front. That's going to be sine 2x.
Professor, shouldn't it be a plus sign?
Plus 5 for where?
Right, 1 plus, like when you put 1 minus sign, shouldn't it be 1 plus sign?
No, it should be minus because sine squared plus
Oh.
cosine squared,
Okay.
right? So in order to get the cosine, we have to subtract sine on both sides. I mean sine squared on both sides. Right, so it's always subtract. If we follow in this one, then we're gonna convert the whole thing to be sine 2x. So we're gonna have 2 sine 2x because we have 2 of sine x, 2 of sine cosine x, right? So I can do give a 4 right here. If I give a 4, that's gonna be 2 sine x cosine x, whole thing square. The square of 2 is a 4. Square of sine, sine square. Square of cosine, that's going to be cosine squared. I didn't do anything here. I just rewrite that because I know 2 sine cosine, that is sine 2x. Square, that's my square right here. So this is what have we done before because we did sine x squared. So we can do the same way to apply to sine 2x squared. Remember we had I had a typo that's going to be double angle. That's going to be 4x in the future, right? So the result will be very similar to what we had before. So on the exam, it's up to you how you solve the problem. All right, so the second exam is very important because one problem could be solving by a different way. Now we try to even and even, odd. So let's do odd with odd. If I change this to be third, I don't think that's gonna be a problem here. Let's say that if I had 3 here, 3 here, can we still solve it? Looks hard, maybe not, it depends, right? How you think it. If you understand this very well, you could solve this very fast. I want to give you 5 minutes about thinking about that, right? Then can somebody you can just tell me what your idea and help help the whole class, how you think about this.
Professor,
Mm-hmm.
can't you just take out either sine or cosine out and then make the remaining the other one?
So why you think about that? Can you help us to understand your thinking? So you
basically, if you take either sine or cosine out, you'll be left with either sine square x or cosine square x, which can then be easily converted into the other one.
So if I put a sine x in front, remaining will be x squared cosine to the third, right? If I put a 1 cosine in front, I'm gonna have sine to the third cosine to the x. So we still follow the U prime method to see if I could get a pair of sine, single sine to cosines, or 1 cosine to a lot of sines. In order to do that, we need an even power for help us to change, to convert. So perfect. Because I say sine squared could change to be 1 minus cosine squared. That's gonna work. This is perfect too, because cosine squared can be converted into 1 subtract sine squared. And the whole thing here will be sine, whole thing here will be cosine. Now we pair with this, pair with this. That's no problem to solve it. Perfect, done. Okay, any questions so far? That's the same way we done before, right? It's just how you pair, how you use our identities to solve the problems. I think we must do a lot of practice so you can handle the trig, because a lot of you had problems on trig, right? So there's some videos I post on our Blackboard. You can watch it. That's gonna be the basic trig and the identities of trig you learned before. So you can watch it to help you to understand more about how to use identities. I'm gonna post this video so you can rewatch it to understand how we think. This is all problem is thinking. Questions? Yes?
Could you also divide it by 8 and multiply by 8?
By 8. Well, which part?
Like in front, like divide by 8 outside of the derivative and then multiply by 8 so that you get 2 to the power of 3.
That's good too. All right, that's good. So your idea is basically, since we have the same exponents, right? So we just gonna rewrite this to be sine cosine x to the third. Then we can convert this to be sine 2x. That's going to be sine 2x to the third. But it depends on how you think, right? I probably going to be prefer doing this way. Think about it, because you have a third. Then you're going to have a lot of terms coming for the sine 2x. Because sine 2x, you have to think about it, right? Because sine 2x, how are you going to do that?
No, my question was to convert the thing into 2 sine x cos sine x to the power of 3
2 sine x, hold on.
by dividing and multiplying by 8.
You have 8 right here, that's what I mean?
Yes, and 2 inside.
Yes. So that's going to be converted into sine 2x to the third. Am I right?
Yes.
Yeah, I said that's right. Then what do you do next?
Right, it's a bit slower than the other methods.
Not really. That's what I said. You have to think about how we do this. What did we do before? That's the same as sine to the third, right? How we do sine to the third? I leave it 1. Then I have remaining square. Then that's basically the same way we're doing right here. Am I right?
Yes.
So it's up to you. Do you have to do this, then bring back the same way, because we are doing the same way anyway, right? So it's up to you. It's the same. The result is, it's good too. If you like to do that, then it's okay. Because this way we're gonna have a lot of terms. This way we're gonna have less terms, because you already merged, right? You have a 2x inside. Okay? Any more
Okay.
questions?
Professor, are you finished grading the first test?
Yes, I did. I post your score on the Blackboard. You can check it right now.
Okay, thank you.
Right, so what I'm gonna do, I think this is good enough for today. Give me 1 second, I need to stop the recording. So we're gonna discuss more about the exam and for our plans for our whole semester. Right, so this, we don't have to record it.